Welcome, Mindsetters, to this session of grade 11 maths. Guys, I hope you guys are nice and ready. Make sure you guys get on the page and get chatting to us. But actually, we have Natasha here today who's going to be taking us through maths today. So, Natasha, what are we going to do?
Hi, Ty. It's great to be back. I hope you guys have all had a great holiday. Ty, we're going to do a bit of data handling with grade 11s today and just build on the knowledge really that you guys got from grade 10 and do a little bit more variance and standard deviation.
All right, cool. So while Natasha makes her way to the board, Mindsetters, you know the drill. Get on the page. I know you guys are still a bit juiced up from the winter school, but make sure you guys get on the page and get chatting to us because we're back to the same prizes. Make sure, guys, you post so you can get this awesome Casio calculator sent to you and this awesome labeler. And I want to send a quick shout out and thank you to Liberty. Thank you for sponsoring the shows. But make sure, Mindsetters, you get on the page. That's the most important part. Chat to each other, talk to us, so I can talk to you and Natasha can talk to you so he can help you. If you guys don't chat to us, we can't help you. Simple as that. But for now, I'm actually going to now keep quiet because this is where I hand over to Natasha. Natasha, take it away.
Thanks, Ty, and thanks for joining us, grade 11s, and hopefully a few grade 12s as well who need a little bit of revision. As I said at the start, we're going to look at data handling. And guys, remember, when we're talking about data handling or statistics, we're talking about the collecting of data, representing the data, and analyzing the data. So it really is quite a real-life application. You know, everyone always asks, well, when am I going to use this? Stats is one of these sections that's really involved with real-life application of real-world problems. Okay, so let's have a look at what we're going to look at specifically in this lesson. So you guys will remember in grade 10 you learned quite a few terms and you did quite a few basic definitions, and that I'm going to do a little revision on what those terms are. But specifically today we're going to look at standard deviation and variance. All right, and then right at the end of the lesson we'll hopefully have some time to look at the Odhav curve. All right, so this chapter really gives you an opportunity to build on what you've learned in grade 10, as I said before, and you also do a little bit of probability, which we're not going to touch on today. And the work is really practical, and through the problem solving and activities, you will end up mastering methods for collecting, organizing, displaying, and analyzing data. You're also going to learn how to interpret this data, and very, very important, guys, is do not always accept what you are given at face value, okay? Because the one thing, and this is one of those sections that can really be manipulated, and people can really show you things that they want you to see. So it might not be a true representation of what's going on in the world, and so you've got to be really careful when you interpret statistics, okay? Don't just take everything as a given. So an important point here is do not accept everything at face value, because the data can sometimes be abused and really falsely prove or support a viewpoint. So statistics can be manipulated in many ways that can be misleading, and as I said before, you need to analyze some of the ways that statistics can be manipulated. You can have this changing of the scale to change the appearance of a graph, so make things look better than they really are. And you can also get omissions, biased selection of data, and a whole lot of other things. And here we're talking about, let's think of a real world example. If we want to think about the number of people who access the internet on a daily basis. Now, there are lots of different groups of people that you can use to do this analysis on. But if you only look at a group of people who have access to a computer, immediately your data is already biased, because if you want to know on average how many people around the world access the internet, you need to have an unbiased sample. But if you sort of restrict your data to only people who have computers, immediately you're looking at a biased set of details, you see. And this can give you an incorrect version of what is really going on every day in the world, how many people are actually accessing the internet. So be very, very careful, because omissions and biased selection of data will lead to false conclusions. All right, so as I said, we're going to just remind you a little bit about some of the important definitions that you've learned before. All right, one of those definitions is quantitative data. What was quantitative data? Hopefully you guys remember that quantitative data, we're talking about discrete data or continuous data. Now with discrete quantitative data, all right, what we're talking about here is values that can be represented by integers. So for example, if we're looking at the numbers of pupils in your class, those are integer values. You're not going to get like 1,2 pupils, all right? You're going to only have whole number values. So discrete quantitative data, things that are represented numerically as integers, all right? So we're looking at the number of pupils in the class, the number of molecules in a chemical solution, or the number of SMSs you send per day, anything that involves integer values, all right? Continuous quantitative data, and you also remember this being represented on a histogram, your continuous data. These can be represented by real numbers. So for example, the height or mass of a person. Now, if you think about height, it's, you know, you can get people that are exactly 1 meter tall or whatever the case is. But with height, it's a continuous thing. You can have like 1,56 meters, someone who is that height. So that is what we regard as a continuous a sample or a continuous data set. All right, so we're looking at any kind of distance, time traveled by a car or phone call or anything like that. All right. We're going to move on to measures of central tendency, and some of these terms you will remember from grade 10. A mean, all right, another way we say the mean is the average. Another word for the mean is the average, and it really is just the sum. So we add up everything in that set of values. You add all your values together and you divide by the number of values in the set. Okay, so, and I mean, a lot of you already apply this in your everyday life or in your class life, because if you want to find out what is the average score that you got for your maths, you know, in your maths class, you'd add up all of your maths marks and then divide by the total number of tests. It'll tell you whether you're a C student or an A student or a B student or whatever the case is. So the mean or the average is just the sum of all your values divided by the number of values in the set. Okay. Another important term is the median. The median is the middlemost, or the value with the central position in your data set. So if you arrange your numbers or your values from in ascending order, so from smallest to biggest in ascending order, all right, so if you order all your numbers, the middlemost number, if we're dealing with an odd set of numbers, that will be your median. If you're dealing with an even set of numbers, it will be the average of the two middle numbers. All right, so remember your median, you have done this before in grade 10. It is the value in the central position. Okay, and there's different ways to look at it. It depends on whether you're dealing with an odd set of numbers or an even set of numbers. All right, and the important thing about the median is that exactly half of the values from the data set are less than that number, and exactly a half of them are greater than whatever number your median is. Your mode is the value that occurs the most frequently or the most often in your data sets. All right, so those were just a reminder of your measures of central tendency. So there we were looking at your mean, your mode, and your median. Okay, you guys will hopefully remember all of this from grade 10. Now, in grade 11, a very, very important thing that you look at is measures of dispersion. Now, what is measures of dispersion? Now, dispersion is just really a general term for different statistics that describe how the values are distributed around the center of the data. And there's different things that we use to measure dispersion, one of those things being the range, which is a term you would be familiar with by now. The range, remember, is the difference between the maximum value and the minimum value in a set. All right, so your range, the difference between your maximum and your minimum value in the set. All right, just remember while we're on this range, sometimes you can get data that's a bit skewed. All right, so if you think, for example, about the heights of different people in your classroom. You might have someone that's really, really tall, like maybe 1.8 meters and is vying to be on the rugby team, and then you might have someone who's really, really short, like myself. So you could have data that's really, really skewed. So the range, is not really an accurate measure if we're looking at dispersion, because it can be skewed to one side by what we call outliers. So you might have this guy who's really, really tall, already 1.8 meters, and he's only in grade 11. So that's going to tend to pull the data to one side, okay, which is not really an accurate reflection of the general heights of everyone in your class. All right, then quartiles. The quartiles are the 3 data values that divide an ordered, when we talk about ordered, we mean ascending order. So it divides an ordered data set into 4 groups, all right? And each group contains an equal number of data values, okay? The one that you're already familiar with is the median, okay, which we also call the second quartile. And we know that that divides your data into 2 pieces. Then you get the 25th percentile, which divides your lower half of data into a half. Okay, because remember your quartiles, you're just dealing with 25% of data each time. So your median divides everything into 2 equal halves. Your 25th percentile or your first quartile, Q1, it divides the lower half of your data into 2 halves. And then the 75th percentile or the third quartile, which we call Q3, divides the upper half of your data into half. So these terms might seem a bit foreign now if you haven't revised stats for a while. But guys, you have done this. You've done this in grade 10. And it's really just going to be you revising some of the examples on quartiles and that to sort of ring a bell again and you remember what all of that is. All right. Then we have the 5-number summary, and what we do here is we summarize specific statistics to give us an idea of what's going on. So it consists of the minimum value in your set, the maximum value, and then your 3 quartiles, Q1, Q2, and Q3. All right, so that's just one of the ways that you can summarize data. Another way is the box and whisker plot, which is really just a graphical representation of the 5-number summary. All right. Guys, there's quite a lot of theory to get through before we actually start doing the practical stuff. So we're going to move on to the last part of the theory, and then I think we'll cross over to Ty just after this and take a little break before we go into our first example. But as I said, there's a lot of theory, even though stats is a really practical kind of subject. Okay, the main focus for today's lesson, variance and standard deviation. Okay, the variance, which we use S squared to represent, is the average squared distance. Okay, that's going to sound a bit confusing, but I'll show you what we mean. It's the average squared distance between the mean of the data set and each data value. Okay, so it's going to be the average squared distance. So we're going to take xi minus x bar. Remember, x bar represents your mean. And we're going to square all of those, and then we sum them all up. And we divide by the total amount in that set, okay, the total number of values. So your variance is the average squared distance between the mean of the data set and each data value. And really, it will make more sense when we do an example. Standard deviation is really what we're interested in, because when you look at variance, which is S squared, you can't really compare it to what you are using in your data set. So for example, if you're dealing in centimeters, variance is going to be in centimeters squared. So how do you compare centimeters squared to centimeters? You can't. Okay, we need to have the square root of that, and that's what we call standard deviation. Standard deviation is the square root of the variance, okay? So as I was saying before, since the variance is a squared quantity, we cannot directly compare it, and therefore we need to take the square root. So what is the standard deviation? It is the mean value of a data set. It is therefore more useful to have a quantity which is the square root of variance, as we were saying, and in statistics, the standard deviation is the most common measure of statistical dispersion. Okay, so that's really, every time we talk about statistical dispersion, more often than not, we're going to ask you to find the standard deviation. Standard deviation measures how spread out the values in a data set are, and it is a measure of the average distance between the values of the data in the set and the mean. All right? An important thing to remember is that if the data values are all similar, then the standard deviation will be very low, okay, to show that everything is quite densely packed around the mean. Okay, so your values will be closer to 0. If the data values are highly variable, then your standard deviation is going to be high and it's going to be further away from the 0. Okay, the standard deviation, remember, is always going to be a positive because you're taking the square root of variance, and it's always measured in the same units as your original data. All right, so we've already touched on all of that. Just a little thing to remember is that these are actually very, very highly effective because we use all of the data values when we work out standard deviation. There are different formulae, which we'll get to later if we're going to work out the variance of ungrouped data and grouped data, but we will look at that when we do an example. And then finally, I just want to quickly touch on this, and it's something that you will really do more about in grade 12, especially if some of you guys are doing paper 3. Then you're going to come across a thing called population variance. So I just want to touch on the difference between population variance and sample variance, but really this is not something for you to worry about in grade 11. So what we do is we make a distinction between the variance, which is sigma squared, of a whole population, all right, and then the variance S squared of a sample which we extract from the population. So let's explain this a little bit more. When we deal with the complete population, the population variance, your sigma squared, is always going to be a constant. All right. And that's always going to be a parameter which helps to describe the population as a whole. But when we look at a sample from the population, which is when we were looking at S squared, that variance can change from sample to sample. Okay, so if you have a whole population of 1 billion people, that variance is going to stay the same for the population, but every time you take a sample, those sample variances are going to be different. As I said to you, it is something that just keep in the back of your head, because if you do go on to grade 12 to do paper 3, then you will come across this whole thing about population variance and sample variance, and you need to be aware of it. However, it's not going to affect the work that we're doing in grade 11, so you don't have to worry about it now. But as I said, when you get to grade 12, you'll be using a slightly different formula for population variance versus sample variance. Okay, so now that I think you guys have all the theory that you need, I'm going to hand back to Ty before we take our first question.
All right. So on that note, mindsetters, I know that was a lot of information, but I hope you guys had your pads on and just making a little jotting down little notes, just little memorizers, so things you can just make sure that you remember for the exam or whatever you need it for. But make sure, mindsetters, you do not disappear, because we'll be right back after this break. See you soon. Welcome back, mindsetters. I hope you had a nice little break. You went and did whatever you had to do, so you don't have to fidget, move, or do anything unnecessarily. So make sure that your mindsetters get on the page. I'm loving all the action that's happening on the page. Like, mindsetters, you don't understand. Like, this is so cool for me because I know, like, a lot of you mindsetters are having fun. So, for instance, I wanted to read this out. Like, I hope you don't mind, Natasha. I'm just going to read this out.
Please go ahead.
So, one of the students said the best way, she actually found this quote, which is so amazing. Lucinda, I want to say thank you, peace up, how are you doing? Maths rocks. Here's a bit of motivation for your mindsetters. The person who risks nothing has nothing, is nothing. Success is not a result of the will to win. Everyone has that great success, and it comes as a result of the willingness to prepare to win. So mindsetters, that's what we're here for. At Learn Extra, we're trying to make sure that you guys are well prepared for success. So you guys can, so when you go into exams, you just go in there and you're like, you know what, I'm ready for this. Because there's nothing better than a prepared mind for a test. Because if you don't prepare and you don't do your revision or you don't work at home, the thing is, the likelihood of you guys actually passing is slim to none, because you need to make sure you put in the work. Because if you don't put in the work, there's no results. And mindset is, again, I want to make sure that you guys remember that you guys need to keep posting on the page to win these awesome prizes. This Casio calculator, we've got so many stacked up, like so many. Like, I was even like having to carry boxes home. No, I'm joking, I didn't take any boxes home, so so Screen doesn't have to check me when I leave. But anyway, mindset is, make sure you get on the page and keep posting. Post awesome stuff like this. Whatever you want to share, if you want to let us know, all the better. And remember, these are up for grabs. So anyway, I'm going to hand over to Natasha, who's going to take it away. Natasha, take it away.
Thanks so much, Ty, and I hope you guys are getting all your questions in. I mean, Ty is quite a good motivator. All right, so as I said before, we're going to look at standard deviation and variance, and it's all going to make much more sense with an example. We're going to look at two different examples. Right now, we're going to look at an example using ungrouped data. Ungrouped data just means we're looking at discrete data values. So we're just looking at integer values. We're not looking at continuous data just yet. All right, so with our ungrouped data, we're just looking at integer values. And in this case, we're looking at chess scores. All right. Now, guys, with your ungrouped data, the formula that we're going to use, remember, we're dealing with variance. Like I said at the beginning of the lesson, most of this lesson we're going to look at variance. All right, the formula you use for variance is sigma squared is equal to the sum. Remember that symbol there means sum. It's the sum of all the squared deviations from the mean, which is just the x value minus x bar, which is your mean. We square all of that, we add everything up, square it all, and then divide by the total number of points. Okay, this formula looks scary, but it's one of those that you don't need to remember because it will be given to you on your formula sheet. Okay, I'm going to go through this example in quite a lot of detail. I'm going to show you step by step how you work out the variance for ungrouped data. We're going to do it in less detail when we get to the one with grouped data. But for now, with ungrouped data, we're going to go step by step how you should work out the variance using the formula. Okay, so we can do this using a table method, or we can use your calculator. Now, it is advisable to learn how to use your calculator, especially with grouped data. It becomes extremely difficult, extremely long and bothersome to use a table. So you need to know how to use your calculator, but we're first going to do this without a calculator. Okay, first thing to do is to work out the mean. All right, so remember the mean is just going to be the sum of all your values. So we're going to add up all of the xi's. All right, we're going to add all of those values up and then divide by the total number. Okay, so let's have a look at our question so we can work out what those xi's are and what the n is. All right, they say that a chess team consisting of 10 players, all right, scored the following points during the year. So therefore, our n must be 10. Okay. And they give you the points that they've scored over the year. They ask you to work out the standard deviation. Remember, standard deviation is the square root of variance. The first thing we need to do is to work out the mean. So how do we work out the mean? As I said before, we calculate the sum of all the x values, our x values being 23, 34, 39, 40, and so on and so on and so on. We add all of those together and we divide by n, which in this case is 10. Okay, so let's have a look and let's see if I've got some space to put that down. All right, we're going to try and sneak it all in here. So we add all the values in. We say 23 plus 34 plus 39, and we carry on adding like this all the way to the very last number, which is 76. We add all the way up to 76, add all of those together, and then divide by n, which is 10. Okay, guys, so if you have your calculators ready, and if you know how to do it in stat mode, great, go for it. If not, do it manually. Add each of the 10 values together, divide by 10. Okay, we'll give you a few seconds to do that. So add 23, 34, 39, 40, 42, 53, 56, 62, 68, and 76. Divide all of that by 10, and hopefully you'll all get your mean to be 49,3. Okay, so as I said, just add all of those values on your calculator, divide by 10, and you'll get a mean of 49,3. So that's the first step. Remember, we're not looking for the mean, we're looking for the standard deviation. But in order to work out the standard deviation, we need the mean. Okay, which is why we did that. All right, let's move on to the next step. So step 2 and 3, which I'm going to do together in this table, we calculate the individual deviations. Remember, what we mean by individual deviations just means the difference between the x value and the mean. We just calculate those differences, and then we square those differences, and then we add everything together, and we're going to plug it into our formula in a minute. Okay, so I've done a few for you. All right, so the first thing we've done in this table is I've got a column that says points scored. Now remember, we're talking about a chess team of 10 players, and the points that they scored were 23, 34, 39, 40, 42, 53, 56, 62, 68. Okay, let's have a look. 62, 68, and 76. Okay, so 76 is the one that's missing here. So I'm just going to put that in. Okay, so points scored, we just take everything down as they gave it to us in the question. The next column is going to be the difference between the x value and the mean. Okay, so in the first case, it's 23, which was our points, minus, remember we worked out the mean to be 49,3. So we say 23 minus 49,3, and we get minus 26,3. Okay, and we just go work our way down each value. Then I'm going to go 34 minus 49,3, and I get minus 15,3, and then the same thing, 39 minus 49,3, and you get minus 10,3. Okay guys, so you work all the way down. I'm going to do the last one for you, which is the one with the 76. So we're going to say 76 minus 49,3, and then we're going to call up our calculator to see what we get. All right, so it's going to be, hopefully you guys can see the calculator. So it's 76 minus 49.3, and we get, and we don't want it that fraction, we get 26,7. Okay, so on our table, we're going to put the difference down, which is 26,7. Okay, so we've completed the second column, which is just showing us the difference between each of the x values and the mean. Okay, once you've done that, you need to have a third column, which is going to be the square of those values. Now the reason we do this, because if you guys tried to add the second column up, if you just took all of these values and you added them up, those are just the deviations from the mean, not squared, you're going to get 0. Okay, eventually it's just going to all average out to nothing. So therefore what we've got to do is we actually have to square each of those values and then add everything together so we can put it into the formula. Okay, you can try it. If you've done the second column, add all of the values up, you're going to get 0. Okay, it really, you can't go anywhere from there, which is why we've got this formula where we've got to square each of those individual points and then add that all together. All right. So all we're doing in the first one, we take minus 26,3, square that, we get 691,69, and you do the same thing as you go down. I'm just going to do the last one for you, which is 26,7 squared. All right, we've still got the answer there, so all we need to do is press the square button, and we get 712,89. So my last value here is going to be 712,89. Okay, once you guys have this column, all right, the x minus x bar squared, you're going to add all of these values together. Okay, so you're going to add all of those values together, see what you get, and then we're going to divide by n, which is 10. Okay, so I'm going to do it with you guys. Okay, so let's add all of that together. Let's see what we get. All right, and I'm just going to keep the calculator on the side here so we can add all of this together. So let's start. So we've got 691.69, and you can see, guys, that this is actually quite a tiresome method to do this because it's going to take us quite a lot of time. So we need to be able to do this on the calculator without doing each of the, squarings and addings and all of that. All right, so it's 106,09 plus 86,49 plus 53,29. Then we've got 13.69 plus 44,89 plus 161.29. All right, I'm just going to hit an equals there, plus 349.69. And then lastly, the last one we worked out, which was 712.89. All right, so altogether, we get 2454.1. All right, so let's write that down. 2454.1, the sum of all of these. 2454.1. And then to find the variance, we're going to have to divide that. Remember what our formula said? It's going to be the sum of all of those values squared divided by n. Okay, so it's going to be 2454.1 divided by n, which was 10. Okay, so we call up our calculator again. The value is still there. We're just going to divide by 10. And we get an answer of 245.41. Now remember guys, this is the variance, and really we can't compare this to anything. I mean, you can see 245.41 is so far away from the individual scores, which was 68 and 56 and all the rest of that. So now that we've got our variance, remember we were looking for standard deviation, not variance. So now that I have the variance, all I need to do to find the standard deviation is take the square root. Okay, so we square root that, square root the previous thing, and let's see what we get. All right, on our calculator, we've still got the answer there, 245.41. So we're just going to say square root of that answer, and we get an answer of 15.66566. If we round off to 2 decimal places, it's going to, or to 1 decimal place, it's going to be 15.7. Okay, so therefore the standard deviation is 15.7. So that means the marks roughly have a standard deviation of 15.7 from the mean. Okay, now guys, hopefully you all agree that that is quite a lot of work. And while you do need to know how to do this, you do need to know how to work out this table. It can be very time consuming. So unless you're specifically asked in an exam to show this working on a table, you want to be able to do this on your calculator. Which now we're going to take a deep breath and we're going to show you the calculator steps. And I know that everyone's really lazy, and you should be when it comes to this section. So I'm sure you're all really happy that you're going to learn how to do the calculator work. Okay, so I'm going to call up my calculator again, and you can follow on your screen. I'm going to show you step by step what you need to do. Okay, first thing, clear everything that we have. We want to have this calculator in statistical mode. So we hit mode, the mode button, and you can see it comes up with 1 comp, 2 stat, 3 table. We want stat. So therefore we hit 2. Okay, then you see another whole lot of figures that pop up here. All of these have something to do with statistics, but we're interested in the one-to-one variance. Okay, so where we're dealing with one variable, and so we're going to hit the button that corresponds with one-to-one, which is number 1. Okay, and then immediately you see this kind of column, 2 columns or 3 columns that pop up. Okay, under the X column, okay, which is under that one there, you are now going to put in all of the numbers, all of the chess scores that we have. So, and I'm going to have to move the calculator just now so we can see all of those numbers. We're going to put in the 23, 34, and so on until we get to 76. Okay, so let's start. So first thing you do is you enter 23. Okay, and we go equals, and you see it pops up into that column under X. Okay, really easy. Then we're going to go 34 equals. Okay, and I can't see the other numbers, so I'm just going to move this across. So we've got 34, the next one is 39. Hit the equal button, and you see it falls nicely under the column of X. So we've got 34, 39, the next one was 40. And then we've got 42. All right, once again, guys, I'm going to have to move the calculator across so that we can see the rest of these values. So we've got up to 42. Now the next one is 53. And then we've got 56, 62, 68. And guys, you notice that I'm hitting equals after every one. and then 76. Okay, we do have 10 numbers in our data set, so that is correct. Okay, once you've got all of your numbers entered, this is important. You need to get out of this whole system, otherwise you're going to start recording numbers that are not in your data set. So what you need to do is you press the AC button, okay, and it takes you back to the beginning of the screen where there's nothing there. All right, we want to find out what the variance is. So we go Shift, and you see on your calculator button 1 says stat, you hit that, and then you come up with all these different things that you can use. So 1 says type, 2 data, and so on and so on. We're interested in the variance, so we're going to hit key number 4. Okay, and I see on the board here I actually have it written down wrong. I've got stat and then 5 variance, but it's actually not step 5 in variance, not number 5, it's actually 4. Okay, and we're looking for the variance, so we're going to hit key 3. Okay, so you see you've got all these different options. You've even got an option number 2 which says X bar, which is your mean, so you could work out the mean from your calculator, but we want the variance, so we're going to hit number 3. And if we did it correctly, then yahoo, we get exactly what we did when we did it manually. Our answer is 15,6655 and so on. If we round this off, we're going to get an answer of 15,7 for the variance. Okay, so I hope you guys found that calculator steps quite helpful, and you really do need to know how to do this for your exam. Just remember, if you are following on the board, please change that 5 variance to 4 variance. You're going to hit calculator button 4 when you get to that step. Okay, guys, so hopefully you found that quite informative, quite useful. We're going to cross back to Ty, who I think will take us to a break.
Yes, you don't have to think about it. I'm obviously going to take us to break. But anyway, on that point, mindset is, the page is still a bit quiet. You could do a lot more in terms of getting your friends to tell friends to tell friends to make sure that they also join you on the mindset page and join in and watch you. Because guys, the whole point is to build as big a network as possible so you mindsetters can talk to each other from all over the place. We have mindsetters from Malawi, from Zambia, from Kenya, from South Africa, from Botswana, from all over who are watching the show. So mindsetters, hey, just pass it on. This show is international. So if I do give you a shout out, probably people in like Zambia or Zimbabwe or somewhere else are also hearing you. So mindsetters, make sure you get on the page and talk to each other. That's why it's all there. But for me, I'm gonna make sure I'm gonna take you guys to a quick ad break. But before that, I'm also gonna let you know that I will be posting up today's challenge question before we tackle it in the last segment. But for now, I'm gonna see you after this break. Welcome back, mindsetters. I hope you had a nice little break. You went to do whatever you had to do. But beyond that, I need you mindsetters to make sure you're paying attention right now. Because right now, you're gonna have to multitask. Because you're gonna have to listen to Natasha. But at the same time, you guys are going to have to make sure that you're paying attention to the actual challenge question for today, because that's where we're going to find our winner. So mindsetters, you kind of have to do both, yeah? We're going to make sure you guys do both. But pay attention still while you're writing the challenge question. Make sure that you're listening and learning what Natasha's saying. But for now, I'm going to hand over to Natasha. Natasha, take it away.
Okay, great. Ty, as Ty said, we're going to have a challenge question up for you guys, all based on representing cumulative frequencies. So hopefully you guys will be able to answer that question with no help. Otherwise, we will give you the answer at the end. Now, guys, we're going to look at an example on grouped data. Remember, grouped data, we're talking about continuous data in this case. And they tell us that the shoe sizes of a group of 50 grade 11s were recorded, and then they summarized it into this table. Okay, so we have that, the shoe sizes 4, 5, 6, 7 all the way to 12, and then we sort of grouped it. Okay, so this is actually not continuous data, but this is just grouped data so that we've actually recorded the frequency. Remember, the frequency is how often that specific thing happens. So for example, shoe size 4, 2 people have shoe size 4. All right, and we've got the frequency for each of these as you go on this table, okay, and going all the way from size 4 to 12. Okay, so they give you that table, they say calculate the standard deviation. Now the formula you're going to use to work out standard deviation, if you're doing this manually, is going to be sigma squared is equal to the sum of all the squared deviations from the mean times the frequency. So you're going to find the sum of all the frequencies times the squared deviations, and then you're going to add that, you're going to divide all of that by the total or the cumulative frequency. Okay, the formula looks scary and it is a lot of long work if you're doing this manually. So have a look here. If you're looking at the table, this is what you're going to do. You're going to have to put in each of your x values, then each of your frequency values, then the difference between each of those. You're then going to have to square all of that, then times all of those by the frequencies, add all of those up, and then divide by the total frequency or the cumulative frequency. Hopefully you guys can all see that this is way too much work to be doing. Okay, you need to know how to use your calculator. So for this example on groups data, we're not going to do this on the table. It's going to take us probably this show and half of next show if we were to do this table. We're just going to use the calculator. Okay, so if you guys don't know how to use your calculator to work out the standard deviation, then now's the time to get out your notepad, make notes. Okay, this is what we do. So we've got our table with all our shoe sizes. Here's our calculator steps. Very, very important thing is you have to make sure that you put the frequency mode on. Now guys, this is important because remember all the data is given to you with frequencies. So they're telling you how often that specific size happens. So we need to have a column for frequency on the calculator. So we need to put the frequency mode on. First thing to do. How do you do that? Okay, so call up your calculator, or if you've got it at home, just follow on your calculator. To put your frequency mode on, we go, hit the shift button, setup. Okay, so you get all of these different things coming up. We're going to just scroll down a little bit, okay? And we see that there's a button that says 3 stat. If we hit that button 3, it says frequency 1 for on, 2 for off. So we're going to hit button 1 because we want the frequency to be on. Let's see how this changes your statistical table now. So remember from before, if I want to call up that table, I go mode to stat, 1 to 1. 1 is to 1 variable because we're only dealing with 1 variable. And look at what happens. Remember in the previous example, we only had 1 column with the x. Now we've got another column that says frequency. Okay, so this is the table we're going to use. I'm just going to have to scroll up a little bit so that we get our values and we can enter that into our calculator. Okay, so you've got your table, you've got your calculator set on the frequency mode. We're going to enter under X all of the shoe sizes, under frequency, the frequency that they gave us. Okay. So let's go. Remember, shoe sizes go from size 4 all the way to 12. So in X, we go 4 equals. Then we went 5, 6, all the way to 12. So we've got 6, 7, size 8, size 9, size 10, size 11, and size 12. Okay guys, you'll notice that I haven't put anything in the frequency column yet. So what I'm going to do is I'm going to go back up, all right, or all the way to that side and go all the way to the top. All right. And we're going to go quite slowly so that I don't miss it. Here we go. So we started with size 4, right? In the frequency column, you can see 1 is written there, but the frequency for size 4 was not 1. The frequency was 2. So under frequency, we're going to hit 2. Okay, it moves on to the next one. Size 5 had a frequency of 4, so we put that in. Next one, 4 again. Next frequency was 8. Then it was 7. All right, so we're just going to move the calculator over to the other side so we can see what the frequency was for size 9. All right, let's just close that layer. Okay, let's try this again.
Mindsetters, just so you guys make sure you remember, do not forget, guys, as I keep saying now, make sure you keep on posting to each other. As I said, this page is international. It goes all over the place. You get to chat to so many people across the world, and we're trying to build the network as big as possible. And remember, guys, much like the 10,000 party, we're trying to get to 20,000. So we can't just get 20,000 if it's you by yourself. You considering this is maths, you get the math of that. That doesn't work. So you have to tell your friends to tell friends to get on the page and join you, because it's so important, so important. And especially what even better is that you guys can actually start working together as groups. You sit down, get a couple of friends, come together, watch at your place, or have a couple of snacks there, and you guys can work through these things all together, which is a lot better. Well, I'm just saying my 2 cents there. But you know what? I'm going to let Natasha continue. Natasha, take it away.
All right, thanks, Ty. So we've gotten rid of all of those ink layers, guys. Let's get back to putting in the numbers. So we're at size 9. We saw the frequency there is 12. So we're putting in equals. Then for size 10, the frequency there was 10. So we put in a 10, and I've got an ink layer up again for some reason. There we go, 10. And under size 11, there were only 2 people with size 11 feet. And finally, 12 was 1. Okay, so that can stay as 1. All right, guys, once you've got all of those values entered, okay, so we've entered all of the X values, which is the sizes of the shoes. We've entered all of the frequency values. We now need to clear all of this out. So we're just going to say AC. All right, if we can close another ink layer, there we go. All right, AC, remember now we're trying to work out the variance, so we're going to call this up on our calculator. We go shift, stat 1, and then we've got the 1, 2, 3, 4, 5 coming up again. We're going to hit button 4, and we're interested in the variance, so we're going to say 3 and equals, and we get the variance as 1,8829. So therefore the variance, or sorry, the standard deviation is 1,8829. So therefore, all right, and for some reason I've got ink layers just coming up all over the place. I'm not sure what's going on there. But anyway, we've got our standard deviation as 1,88297, and therefore we did it really quickly on our calculator. Okay, guys, you can do this using the table, but as I said to you, it's going to be really, really long. So just do it on your calculator. Now, it seems like we're running out of time, so I'm not sure if we're going to have time to put up those answers right now on screen for that challenge question, Ty. So let's see how far we get. I don't know if you want to talk a little bit about that challenge question while I try and close the ink layers.
I will definitely do that. So mindset is, you guys are probably sitting there on your phone, whatever phone you're at. We can't mention the brands, but you've got your phones in front of you. Make sure, or if you're on a computer, make sure you go to the page, to the main page, and you'll see there, it's highlighted, so it should come up right at the top of the page. So make sure you guys get on the page and look up the challenge question, because if you don't, well, then you're going to miss out on these awesome prizes, which means that's completely pointless. Because I know a lot of you have been saying, oh, but we want calculators and we want labelers, so post. That's how you guys can win. But actually, I'm going to actually hand over to Natasha, who's going to actually go through it now.
Right, I'm going to actually fly through this, guys. The first question is, we've got this for you to try at home. We've got a table with your marks frequency and your cumulative frequency table. First thing we need to do is complete the cumulative frequency. All that means is add your previous frequencies together. So the first one's just going to be 6, and it's going to be 18. And remember, all I'm doing is 6 plus 12, 18. Then you're going to get 56, 98, 110, and then the last one, 120. Okay, so therefore, if you add up all of your frequency for this accounting examination, we see that out of all the grade 11 learners, our cumulative frequency is 120, which means we're looking at 120 learners. Okay, so that's done, easy, 2 marks. Then they say draw the Odhav for the given data on the grid provided. So you will be given a grid to do this in the exam. I'm going to once again fly through this. Remember, this is really just your Odhav curve. It's just really a graphical representation of your cumulative frequency. Okay, so I'm going to be a little bit untidy. Please forgive me because I am dashing through this. Remember to label this. So we're looking at marks on the x-axis, and on the other side it's our cumulative frequency. Okay, guys, and all you're going to do to plot this Odhav is you're going to plot the top end or the upper end or the upper bound with the cumulative frequency on this graph. So we're going to have on the x-axis the marks, and then your cumulative frequencies On the y-axis, remember it helps you to read off a number of percentages and all of that. So you're going to plot, and I'm just going to show you very, very quickly. You're going to have noughts, 50, 100. So these are our marks, 150 and 200. That's all of your marks. And then on the y-axis, it's going to go from nought, and then we've got 20, 40, 60, 80, and this is going to go all the way up to 140. And when you plot this Odhav, your curve should look something like this, hopefully a lot neater. But it's going to look something like that, guys. And the only way you're going to get this curve really, really easy is you're going to plot each of the upper values with your frequency. So your first point is going to be 30 and 6. Your next point, 60 and 18. Then 90 and 56. And you're just going to plot each of those points as you go down, across on your marks, and then up on your cumulative frequency. They then say use the Odhav to determine the median mark. Remember, the median's the middlemost mark. We were dealing with 120 people here. So the middlemost mark will occur at that point 60. You would go across. Obviously, yours is going to be more accurate than mine. And you're going to drop down from the 60. And you will read off from your graph that the median point, or the median mark, was actually 91. Okay, so guys, I flew through that, I know, but hopefully you got the gist of that. And just remember, if you want to revise all of this, please just go through your textbook, go through your old notes, and go over all of that statistics and data handling that you've done so far. I think next week we've got another lesson for you grade 11s on stats, so stay tuned to find out more about stats next week. Okay, so yeah, hopefully that was useful, Ty.
All right. And on that note, since we sped through that, I hope your mindsetters had a great time and you guys had fun during the show. But this is where we sign off and we say we're going to see you next time. And don't forget, guys, always prepare, revision, study, and practice. That is the greatest tool for you guys to have success in the future. But from us, we're going to see you next time. Cheers.